Welcome to this lesson on vectors in two dimensions.
Hello, today we'll master the basics of magnitude, direction, and how to work with vectors in a 2D plane. We'll cover everything from simple components to vector addition. A vector is a quantity that has both magnitude and direction. Think of it as an arrow. The length is how much, and the tip shows exactly where it's going. Magnitude is essentially the size or length of the vector. In a two-dimensional plane, it's calculated using the distance formula from the origin to the vector's tip. Direction can be mentioned in various ways, such as using compass points like north or east, or more precisely, using mathematical angles. In physics and math, we typically measure the angle from the positive x-axis in a counterclockwise direction. This is our standard reference for 2D vectors. We represent a vector in 2D using its x and y coordinates. This point, xy, defines the vector's head when its tail is fixed at the origin. Every 2D vector can be broken down into two perpendicular parts, the x component and the y component. Think of them as the shadows of the vector on each axis. For a simple example, a vector with a magnitude of 5 at an angle of 30 degrees has an x component of 5 times cosine of 30 and a y component of 5 times sine of 30. In a more difficult case, like a vector in the third quadrant, you must be careful with the signs of the components. Both x and y will be negative here. When adding two vectors, we can use the cosine law to find the resultant magnitude. This relates the sides of the triangle and the angle between the two vectors. Consider two forces acting at an angle. By applying the cosine law, we can calculate exactly how much total force is being applied and its resulting direction. Let's solve this using the standard resultant formula. With force A at 10 newtons, force B at 15 newtons, and a 60-degree angle between them, the magnitude is approximately 21.8 newtons. Alternatively, we can use the component method. First, resolve each vector into its x and y parts, sum them up to find the resultant components, and then calculate the final magnitude. To recap, vectors have magnitude and direction, can be split into components, and added using geometric laws. These are the building blocks of physics. Great work today! You now have a solid foundation in two-dimensional vectors. Keep practicing these calculations to master the concept.